Well, hello there. Welcome to tuning in to something I thought I wouldn't be
Thank
doing
you for the follow.
ever, but I'm here. I am doing a Twitch stream, my first ever. So if there are any crazy things happening, well, it's always the first time for that. So if you haven't seen my work before, well, my name is Eric, and hello again. And I am a somewhat of an enthusiast for R, the language or statistical computing, easy for me to say. And I also dabble in a lot of open source work, and in particular a lot around Linux, and I am part of a nice community for that. Okay, I'm hearing a bit of an echo from somebody. Let me see if I can get to the bottom of that. I knew that might happen. I have some ideas. Let me see. Okay. I bet I know why. Maybe something else. Yeah, I have an idea. No, maybe not. Okay. Is on 2 embedded C. Yeah, okay, well, anyway, you can see I'm getting some nice help from my friends on the Ubuntu Mate community, that there may be an echo going on. Oh gosh, so let's see. Okay, I'm gonna try a couple things here. All right, is that any better? Hopefully so. I changed one switch here. I was fiddling last night, and you know, that always things happen. Still echoey. Okay, let's see. Microphone scene. Let's try. I need to make my... Yeah, I just got some new hardware that I told a couple of you about, and I'm wondering if that may have should have invested in that after all. I'm doing some OBS. Okay, got it. I think I know what it was. All right, thank you. Yep. Okay, good. So, yeah. Yeah, that's it. Good night, everybody. Okay, now back to the real fun stuff while we're here. So, I figured, so it's my first time on Twitch trying one of these, so I thought let's get to some kind of like some reasons for why I like R so much. Kind of my little bit of my history with it, but I have some of my friends here in the chat, Yannick and Monica in particular, that have been asking me for a nice little intro to it, what we can do with some data. So I thought, why not? Let's give it a shot on Twitch. So we'll just dive into some basics. And for those of you that kind of know R already, this will be a bit of review, but we have a fun data set to look at. So we'll make it fun for everybody. So let me, first I'll get the, check my buttons work here. That is the chat, and it's looking good, I think. So now let's go to my browser window here. So the first place to go if you're interested in R is the R site itself. It's r-project.org. So it must be, oh, I think I know. All right. So whatever I did in that other scene, how about that? I think I may have solved it because there was one source that was unmuted, I think. I'm looking at all my sources of audio here. Got it. Okay. I know what it was. Yep. Thank you very much. We won't touch very much from this point on. So R is available cross-platform. It is completely open source. It is And Monica, thank you for dropping in for just a bit. You'll definitely want to see the recording after this. Hopefully I can make sure that doesn't go haywire. So R is, like I said, an open source language for statistical computing. It's actually been around for many years, has origins even before the year 2000. And you might say, a lot of people like to call it the lingua franca of statistics. It is a very kind of a hybrid language, very object oriented, but also lets you do, from my perspective, both the interactive data analysis, when you've got your data set, you want to get some summaries and visualizations, stuff like that. And then you can also build tools around it, interactive, many different systems. It basically is almost like a mini Linux to me for the world of statistics. I can interface with everything that I want most of the time and be able to do lots of cool things, especially with the package like Shiny for web applications. So I really enjoy using it. That's why I have a few efforts in the R community that I'll mention now in case you haven't seen my work before. I'm mostly known for a little podcast called the R Podcast. I can lay claim to say it was the first ever podcast about R. My release schedule hasn't been quite to my liking, but I hope I can resume that as well. I've also joined recently the R Weekly team. This is like a kind of like a curated digest every Monday. We look at the top stories in the R community, whether they're tutorials, blog posts, new packages coming around. So it's really a great way to keep up with what's happening because R is not only changing in and of itself, the community is always adding cool things and learning new uses of it. So on top of being a curator for this, I also do a little podcast that comes out mostly every Tuesday morning, which is my take on the 3 highlighted stories of that particular issue. Just kind of more of a deep dive into that. And if you've heard shows from the Linux podcasting space like Linux Action News or Linux Headlines before that, it is very much patterned in that mindset. And then lastly, I'm also the host and creator of what's called the Shiny Developer Series, where it's basically a video series on YouTube where we meet with the most influential people in the Shiny community, the developers, the practitioners, and even the users just like me that are doing really cool stuff, learning new ways of taking their Shiny apps to another level, you might say production level. And so we've had 19 episodes, and my latest episode will be edited hopefully within the next couple days. And we'll get that released out there. So, okay, so that's a little bit about me. And feel free to ask more in the chat if you have more questions about any of these. But let's kind of dive right into it. So to actually download R, we won't go through the steps because I have a kind of a fancy setup for all of this, but you would just follow the what we call the CRAN mirrors. And then you can choose which operating system to install it for. Windows and Mac are basically binaries. They each have very detailed sets there. Linux gets interesting because anybody who knows the Linux knows there's quite a few distributions out there. But you might say the ones with the most mind share are represented here from Debian, Fedora, Basic Red Hat, SUSE, and Ubuntu. So usually I use Ubuntu on my systems or derivatives of it. And yeah, Yannick has a good question. CRAN is to R, so CPAN is to Perl. Yes, that is very much accurate. It's also kind of like in Ruby, they have their own package ecosystem, or in Node, they also have that. CRAN is interesting though, because there are a lot of humans, like the R Foundation has maintainers to make sure that a package, in order for it to be on CRAN, has to meet certain criteria. And if you don't adhere to those, your package doesn't get there. And they do have automation to check that it installs on newer versions and on many different operating systems. And sometimes it can be a bit cumbersome to get something on there, but it is really like a curated set of packages. And at the time of this, I think we have over, 19,000 packages. It's growing immensely. So that's a very good analogy to it. So again, if you're on something like Ubuntu, it would be very basic instructions here. You can either get it from the main kind of standard repositories, and there are some other repositories out there that can give you more of like a PPA to keep more up to date with that. Now, what I like to do is I actually, what might be shocking to some of you, is that I don't have R on the system I'm talking to you on right now, because I like to use containers for it. So what I've done recently is I have a GitHub repository. I'm calling it RDev projects, where I'm able to now containerize in Docker the R installation and the two development environments that I've been using most lately, so that now I can be very, nimble and agile with the version of R, the version of packages, and keep my system pretty clean. So I actually did my first ever live stream on a different platform was about this setup. And it's on my Shiny Dev Series YouTube channel. I call it the fully containerized R environment with Docker, RStudio, and VS Code. So if you're interested in that setup, definitely check that out. We're not going to obviously walk through that today. But in terms of R itself, the thing that you'll want to do is arm yourself with a nice development environment, because just using R on the terminal, while certainly there are a lot of cool things you can do with that, and if you really know your stuff, you can be very efficient. It's great to have something that kind of shows you what's in your overall session, how to get help for various functions, and other kind of niceties. So in the R community, probably the IDE that gets the most press, the most mind share, is RStudio from the company of the same name. And they offer the desktop edition of their IDE as well as a server edition, which is really interesting because then you can run RStudio from a web browser, which is actually what I'm going to do through the container setup shortly. But it's very easy to download RStudio. It's completely open source. They do have commercial products that my day job invests in, but you're not obliged to use those. And so that is something that I recommend, especially if you're new to the language. Setting yourself up for success at the beginning makes a big difference. So that's that. And then also a space that's emerging lately is the VS Code extensions from the community for R. And I'm still learning the best ways of using it, but my stream that I mentioned earlier walks through kind of my first experiences with, after getting set up, how to use that in practice. So certainly if you like VS Code, you'll want to check that out too. So, okay, let's get to some fun stuff, shall we? Let's look at what it looks like to be in an R session with some fun data. So first, let's introduce the data. There is hopefully at least one listener or viewer here that's going to really like this. But in R, there's practically a package for almost any type of data available. And when I mean any type of data, have a look at this. There is a package that bundles Star Trek data. Yes, it is a package called rtrek. It is actually made by one of my, what I'll call R friends in the community, Matthew Leonowitz. We've actually met at previous RStudio conferences, really sharp guy. And I knew he was working on this at some point because he is a very, very big Star Trek fan. And lo and behold, he has released this as of about a year and a half ago. So we're going to use this. We're going to explore the data sets in this package or the links to an API that this package wraps to start getting into what R can do from an interactive analysis standpoint. So there is lots that we could do today. We won't get into all the package, but we'll just have some fun with it. So, all right. This is what we have called the RStudio IDE. So sharp eyes would see that I'm running this from a web browser and I'm running it on my local machine because it is from a Docker container. But if you had the desktop edition, it would just be another window that you can just interact with. And so I've configured mine a little bit differently than the default layout. I'm using a dark theme. I put my console on the upper right here. But the idea is that R is an interpretive type language. So you type commands, you get instant feedback. Or if you don't get feedback, it's saved somewhere and then you can retrieve it later. So the easy stuff that we can do is we can start defining some object types. And we're not going to do much with this before we get to the data, but you can assign a variable X. You can make it a vector of, say, 1, 2, 3, Y, and then if I can type, let's see, 4, 5, 6. And then in the IDE, you can do keyboard shortcuts to run that. So now we have 2 objects. And then in this environment pane, we see the types of objects we have here. These are called numeric vectors. Vector can be a one or more element of the same type. In this case, they are numeric. And then this is where you start to see some of the interesting parts of the language if we just do a plot of these two, which is very exciting, of course. One thing you might notice is that unlike some other languages, I didn't have to quote these two names. R has different methods to basically take objects that are typed without like a quote or anything delimiter around it. And it's smart enough to dispatch finding that object in the environment. And this comes in quite handy when you get into interactive data analysis. But here I just did a simple, boring plot. And then RStudio itself has this nice tab called plots where you can see these. And if you do more than one, you can kind of toggle back and forth. You can clear it. And so we're going to be using that a little bit today as we get to our data set. Now, to get packages, you can install them via the included function like install.packages. Now you start to see the IDE gives you kind of like tab complete. You would type the name of the package, and then it would go to CRAN and download that all for you. So this is if you're coming from Python, very similar to installing something from PyPy or other repos like that. And then you can see the list of packages you have in this little pane down here in the lower right. And so it'll list them all. And this is one thing that I like about what R does for its IDEs, what RStudio has done, to be honest, is that if I want to get details on a package, I can even just click on the name of it. And now I have all the documentation hyperlinked right here. And then I can read that, try things out, look at example code. I have never had as easy time for this in other languages, being able to get help for various things. So we're going to be using that throughout this exploration of kind of looking at some functions I'm going to do for more of an interactive drill down of data, as well as the package that we're going to be working with today. So we're going to get rid of this and let's start looking at the data we have. I'm going to say playing on the stream. Every R program typically has a .r extension afterwards, so that's easy to do. And let's start loading some of the packages that we're going to use. So the first package I'm going to load is actually what we call a meta package. It's called tidyverse. Tidyverse is basically a collection of opinionated packages created by Hadley Wickham, who is definitely one of the more influential package authors in the R community, to basically have a unified API-like syntax for all types of data analysis pipelines. So whether it's importing the data, transposing it, reshaping it, deriving new variables, and doing some visualizations or other summaries, it is a collection of packages that I'll go on a limb here and say if you're new to R and you just want to get started with data, it's probably your best onboarding ramp for it. Certainly, tidyverse doesn't solve everything, but if you're doing interactive analysis, it's definitely a great place to start. Oh, good. I'm glad you asked, Yannick. Why is it called R? So let's get to some history here. So before R, there was a language called S. S was actually written at Bell Labs many, many years ago. And it is a language that actually has very similar style as R itself, albeit it did not have this rich ecosystem of packages or the CRAN network. But S was written by Bell Labs. It follows a lot of the Unix and Linux philosophy. And then there were two professors at the University of Auckland in New Zealand named Ross Ihaka and Robert Gentleman, who thought, you know, we really like what S does, but it is kind of a commercial entity. We're trying to teach statistics at our graduate courses, and we really like what S can do, but what if we made kind of an open version of it? And they called it R for two reasons, we think. First, it is the letter immediately before S, and second, the two founders just happen to have names that start with R. So that's what we've been conjecturing in the community, and I think that's pretty accurate. And then once they released it and once they set up the CRAN infrastructure, R just started taking off in academia like crazy. And then industry, a little while afterwards, already started to catch on to it because you had these students that were starting to learn R a bit more and the flexibility of it. And now we see it in every industry, different types of workflows. Obviously, data analysis is kind of its bread and butter. But like I said, it can be a direct part of production pipelines and tooling. I do a lot of tooling around R. I really get into the nitty gritty of it, so I can do it all. But that is an interesting history of it. So we have loaded the tidyverse, and now let's load the rtrek package. And so you don't see any feedback here because library just basically registers the functions so they can be typed in and called without having to search for them, basically. So what we want to do now is anytime you're dealing with a package that's kind of new, do what I just said. Let's find rtrek in the... I've installed all this in my container already, so that's why they're showing up here. And then we can kind of see the functions it has, but what a lot of the top packages in the community will do is they'll have a website that's actually, this website here is also generated from R, which is really, you get to really fun things you can do with it. But the key point here is let's kind of get started with things. We can look at how the interfaces with the Star Trek API. So maybe we can start looking at the entities that are in here for these API endpoints and start getting to our data set. So that function looked like it was called STAPI entity. So this is actually a data frame. If we just, and we'll get to what a data frame is shortly. So a data frame, now you're going to wonder what this tibble means. So let me get to that in a little bit. But a data frame in R is basically a rectangular structure of rows and columns where each column in a data frame is a vector of the same type. So in other words, in a data frame, you can't have a vector that has both numeric and character strings as values inside it, because that violates the vector philosophy as well. And so what's neat is that a data frame can have, you know, as many columns as you want. Obviously, you have to deal with memory sometimes, but you can organize things very clearly. And there are many methods in R that deal with data frames very well. But one of the philosophies of the tidyverse is that the data frame is kind of like that central type of object that we can do lots of interesting things with. Now, what is this tibble thing that you see up here? So a tibble is the tidyverse's kind of respin of a data frame that give it a little extra help for various kind of nice quality of life kind of enhancements. So with a tibble, you notice that we printed 10 rows here, and it says with 30 more rows, because what they want to do is not clog your output if you just did a data frame of it instead. Now let me show you what I mean. If I just do as that data frame of STAPI entities, Watch what happens when I print this. Now that didn't look very good, did it? That looked like a bunch of junk here because it printed the whole thing. And so the tidyverse, this Tibble class that of the data frame, what it did is it modified the method of printing the object. So this is where R gets into kind of its object-oriented structure. It has methods for various operations like printing and plotting and modeling, even things like that. So we're obviously going to keep with the default Tibble version of that data frame. And let's kind of take a look at what we have here. So on top of just showing those first 10 rows in the IDE, in RStudio and even in other R development environments, you can do what's called the view function. And now we get basically a spreadsheet-like looking layout where we have all the rows printed here as kind of a snapshot. And you're going to wonder what's going on with this column here called column names. This is actually a list. List actually is one of the most fundamental objects in R. A list can be a collection of any type of object. It does not matter the type. It's kind of like this general bucket of things. And what was something that the tidyverse team did, I'd say a few years ago, is start putting as a column in a data frame a list, because a list actually does not care about what's in it, but a list is a list, so it's technically the same type. So that'll seem kind of odd at first, but we'll deal with that as we go along. So back to this, we can start looking at what kind of data sets do we have here. We have character. I guess that's probably characters of the Star Trek shows and movies. We have technology. We have species. We have spacecraft. That looks fun. Maybe we start looking at spacecraft for a second. So let's go back to the docs here and let's see, once we have an entity of interest, what this package wants us to do. So what we're just going to do is we're just going to copy this code. We're going to modify it here, and then we're going to start exploring it. So instead of character, let's do spaceships. And what I had a little bit of look at this before, and I can't type spaceships. Oh, let's go back to my data set. Spacecraft, not spaceships. Okay, I didn't read carefully enough. So we're going to do spacecraft. Now, what this function's doing is apparently telling us all the pages of results to get, because this is coming from a web API. So most APIs are kind of paginated, so minimize how much data is being returned back at one time. So apparently there's 13 pages worth of data for this package, or for this type of data on the API. So now we know what we want. Now we can see, let's actually start getting the data here. So I'm just going to, okay, I think I know what I need to do. So instead, I'm going to use that same first part of the function. And now we're not going to do page count. We're just going to experiment getting like the first page. And then I'm going to save this as a variable. A lot of people in the community call their data frames DF when they do an object of it. So let's do that. And now we've got something. Let's take a look at what we have. Now, apparently each page gives you 100 observations. That's what we're seeing here in this snapshot. Let's take a look at what we got. So we've got name, registry. Now, the Star Trek fans in this stream should probably know way more about this than I do. I'm just going to have fun looking at it. The status, active or destroyed. I assume these dates are star dates, I would guess. Owners, operators. Oh, this looks pretty neat. Yeah, so we got a lot of different names here. I'm not seeing a lot of numeric stuff other than the status of active or destroyed, but we can probably do something with that. So we can, now we know that this works for one page. We probably want all the pages, right? So maybe what can we do to easily get all of this combined into one data frame? Instead of like, what I could do is I could like call this again and do like df2 and like page 2. I mean, that's certainly valid, but that's a lot of typing, a lot of copy pasting. I don't like to do that. I like to keep things, very clean and hopefully automated with iterations. So what we saw when we called this this function from before is we had 13 pages, right? So what we could do is we could write a function, or actually I'm going to use another package to do this. A lot of programming languages have what we call kind of like iteration or map reducing. And there's a function or there's a package in the tidyverse called purr, P-U-R-R-R. And it has these functions called map. And what map does is it takes a vector of things and then it lets you apply a function on that vector of things. So what we could do is, we know we have 13 pages. We could just do a vector of 1 to 13. And this colon syntax is actually just gives you a numeric kind of index from 1 to 13. And what I can do is I can simply do this tilde to say, okay, go into the function I'm about to call. And we're going to say spacecraft and then page equal .x. So in purr, that .x is a placeholder for this first argument here in the map call. There are certain map functions that can do 2 at once or even more than 2. So that changes how you refer to it. But what we can do now is, let's see df, I'm going to call it df all, and let's see what happens when we run this on everything. So it takes a little bit because I did do some reading. The author of this package is pretty nice to introduce some sleep times in between requests so that we don't overburden the API. So it is taking a little bit of time. So what I can do in the future is I could wrap a function to give me some, okay, now we got something here. This is interesting. Time for debugging. Another important skill to have in any language. It says error in JSON-Lite flatten. Now, JSON-Lite is a package that helps translate JSON data or JSON files into R objects, whether they're just strings or a data frame. So apparently there's something going on with one of these. Now, which one? What could we do to debug this? Now, I have an idea. We can modify this slightly. So we're actually going to change this from calling one function at a time to an anonymous function, which is what the curlies are for. Oh, my friend Afton Steps is here. Oh, yes. So she is one of the more prolific streamers on Twitch with R, and I've learned a lot from you. So I'm glad you can make it. Thanks for joining. Yeah, the setup, you'll want to hear about this next time I come to your stream. It's been a lot of work. So what we can do now is let's figure out at what point did this break. So what I've done in my day job is I'll often use the function called message. Message is basically a way to print something to the console. So if I just do message, hello all, I get that outputted to the console itself. So what's really cool is that there's another package called glue. I told you there's like a package for almost everything, where we can do a wildcard syntax for the iteration that it's on. So I can say importing page. All right. So importing page, and then I put a little squiggly here to say, what do I want? I'm just going to call it I, and I'm going to say I equal .x. Now this should tell us at what point will it succeed. So that all I did is just add another line to like my kind of map call here. and enclose it with a set of curly brackets, because that's typically what we do to enclose functions that are more than one line. You just enclose them in that. So let's see what happens when we do that. And of course, I have a typo, of course. Let's see. So I've got message here. Static. Oh, I have two. That's why. Too many parentheses. All right, let's try that. Okay, now we're seeing some feedback, right? Importing page 2, 3, 4. I probably could, Yannick. In fact, we'll try that. Sometimes I got a little paranoid about being too cute with that, but let's see what happens after this is done. So we got to page 12, page 13. Aha, it's page 13. So what I'm guessing is that there may be something wrong with page 13 itself. Now, the easy way to check is we just do it on a single call here, and let's see if this df fails. Yes, it does. So who knows? Maybe the API has a problem for that particular page, but the easy solution now is just change this to 1 to 12. And then now let's live maybe dangerously, maybe not. Let's just do .x here instead and see if Glue is smart enough to know what .x is. So let's give it a shot again. Yeah, Yannick, you bring up a good point. Is it so much 0 to 12? Now, R itself has indexing start with 1. And from what I could tell, the author of this rtrek package is keeping with the R defaults of indexing starting at 1 and not 0. But that is a valid point. Maybe for some reason the indexing's a bit off there. So the .x trick worked. So that's another nice thing about Glue, is that if you have a variable in your functions workspace that's already scoped out, then you can import that. So we're almost at 10, and then we should have 2 more to go. And we have it. Okay, so we have a bigger, now here's what's interesting, this df all is not a data frame right away. It's a list of data frames because I used map. So map itself has other functions to coerce it into a different object type in R. I didn't do that here just because I wanted to get something quick. But thanks to the dplyr package, we can convert this to an integrated data frame. We have a function called bind rows, and you can feed into it a list of data frames. And I'll just overwrite the previous one. And there we go. Now we have a lot more observations, 1,149 observations of spaceship data from Star Trek. Oh, this is fun. So what are some questions we could ask here? Now, I would guess that each of these ships' names are unique, so there's not a lot we can probably do there. But you are seeing this status, right? What could we do to count kind of like the number that are active or the number that are destroyed? Maybe we could do something for that. So let's do some data munging here. Oh, okay. Our resident expert Yannick says they're not unique. So that would be something we can look at here, is we could summarize how many entries for each ship there are. Now, this is where I'm going to start doing some interactive tidyverse-like pipeline here. And you're about to see an operator that to any of those that are used to Linux will get the concept, but it was kind of new to the R community a few years ago. Is we're going to make a new object, summary. I'm going to take df all, and I'm going to do this. That greater than sign surrounded by 2% signs is what we call a pipe. Those of you in Linux know a lot about what the pipe is. The pipe is when you take the output of one command with the vertical kind of operator and feed it into the next command. A lot of people do that with like string regex and searching for strings. R has that now, and it also, as a version R 4.1, will have a native version of that doesn't depend on another package. So we're going to do some dplyr functions to get to know what we have here. So I'm going to actually try this by memory, but we can do a function called count to say this. So what variable do we want to count? I forgot what we have here, but what's cool is we can expand this. Name, okay, so count. Now let's see if this works. I haven't tried this in a while. Okay, df summary. We have 1,080 observations. So my guess is there's some of these that have been counted twice. So what we can do is we can sort this by frequency, and sure enough, in the RStudio IDE, they have these little arrows here where you can sort a column in the viewer by the frequency. So of course the USS Enterprise, probably the most famous one, has 8 entries here. Now why on earth does that have 8 entries? All right, so let's explore that a bit. So again, I'm just exploring things, so we can just print this to our console by doing a filter. Filter is a function in dplyr, the dplyr package, to subset your data by a certain condition. So we can say name equal, and maybe make sure I USS Enterprise. All right. Oh, okay. So that's, yeah, I don't want to filter this. What am I doing? I want to do df all. Okay. So let's make this a little bigger here. We should probably view this, right? So we can, this is where it gets really fun. You can pipe this into a view call. I saw a few people from RStudio do this, so I figured I'd take that skill too. So now we have 8 entries for USS Enterprise, and they're each looks like a different registry. And then within these registries, we have the status, active, destroyed, or NA. NA, if you're not familiar, that means missing. So that's what we have here. And then it's got, looks like a class UID, an operator UID for some. The rest of them are kind of missing. So there is a spacecraft class.name. Again, I'm not as well versed in the history of it, but there must be another categorization here. But what's cool is that now we know what kind of the overall status of all of these. So yeah, the second one, are you referring to this here? Yeah, I'm not sure what these are here. I can, actually, I'll show you a cool package to view this in a little more web-friendly framework. Let's another package that I like to use for interactive viewing is the DT package. So DT is an R package. Let's see if I have it in here. If I don't, I'll have to install it. DT. Oh, I don't have it. So let's install a package, folks. Install that packages. DT. I use this quite a bit in my Shiny applications. So it's a really fun package to use. You'll see why in a little bit. Okay, so now we're going to do DT data table. And then let's, before we do that, let's save this result as another object. I'll call it df USS. Okay. Then we're going to df USS. Okay, now we got this nice little viewer here. So in RStudio, you can maximize these different viewers or zoom into it. So now we've got a little more nicer display here. So we see kind of a little more friendly version of it. Now the ones that I feel are the most, I don't want to say peculiar, the ones that stick out to me are this second entry here, where basically there is no other data other than the name and the registry. Like, what's going on there? Doesn't even have any of this. So I don't know if that's like the API is just returning something like that or what. So if I was going to do an analysis on this, that would be one that I might want to maybe try to drill into a little more if I had more data around it. But you can see the rest of the fields definitely have valid data for at least the class UID and the class name. So we can maybe do some linkages to that later. Because I kind of recall from the package itself that if we go back, Yeah, now I'm going to go back to my whole view here. Let's look at the API entities then. Whoops, yeah, let me pipe that into a view as well. There was something about star spacecraft class. I wonder what spacecraft class has. I think that's like more detailed information on this. So let's start looking at, we're just going to copy this. I'm not making this a neat file right now. I'm just exploring this. And that was called, let's see. I think that was called spacecraft class with a capital C. Let's see how many pages this has. 7. Okay, not quite as many. But let's do the same technique we did for importing the spacecraft kind of overall data. And let's use that to do like another kind of bigger data frame of everything. And let's do a test here. We're going to do this same thing, but with the last page of spacecraft class, because I suspect that all of these are going to have the same problem. Well, let's just do a quick test and find out. Yes, it does. The last page it tells us is available seems to not be able to be imported correctly. That's fine. What we can do, space class, is we're going to basically take my same map call. I'm going to put it here. We're going to do 1 to 6. And we're simply going to do spacecraft class. And this time I'm going to take the shortcut here. In map, there are variants called df, which this will transform the end product to a data frame right away. So let's see if this works as I hope it does. So now we've got our very silly counter here, but hey, message always works. So we got space class. Now let's explore this a little bit. We're going to use the DT package, data table again. And if you're wondering, when I do this like double colon, what this does is that if you have a package in R and you don't want to load it via library so that all the functions are in your global workspace, you can prefix it by the name of the package and 2 colons to say, okay, just for this function call, look in the namespace of, in this case, the DT package, and so that you can have the rest of your global workspace not have the DT functions loaded inside. And that's easy to tell, where you can start looking at the global environment and you can see all these packages are loaded in my environment, but you don't see DT in here, do you? Namespacing for the win. Yeah, we've had those. We've had those in your sessions too, Afton Steps. Yep, exactly. So I always do that, especially for my Shiny apps, because it never hurts. It never hurts. So let's view this. So let's see what we got here. Whoops, that was the wrong button here. Let's view source viewer. So I recognize the song. So by the way, any of you curious where the music's coming from? I wanted to be a little different than my friends that have been teaching me the streaming ways. I'm doing streaming video game remix music from the Rainwave website. And all these tracks are coming from a site called OC Remix. So they take all these video game soundtracks and they remix it to be their own instruments, their own original compositions. And at least I think it's safe for streaming. They say it is. So had to do something different. So, okay, now we see this data set and we have 527. Oh, there ain't no music. Oh, did I mute that? Oh. I know why. Because we were debugging the, yeah, I've got it. All right, let's see if it's back. Hopefully there's no echo because of it. Let me know if it's there. Okay. Okay, good. Thank you. Sorry for that. And no echo. Phew. Okay. Those of you that joined a little late, we had our fun OBS debugging because of my first time on Twitch, so you never know. So let's look at what we have here. We've got Number of decks. That's kind of cool. Oh, looks like it's got some fun like indicators on whether it's capable of warp speed, where we can go to alternate realities, when it was active. Oh yeah, we can do some stuff with this. I think this is the data set we'll be using now. And what we can do is we can filter this for the entries that we found in the other data set that were valid entries. When I say valid, those rows in the overall summary that did not have the missing values. So what can we do to do this? So what I want to do is I want to all right, I want to basically go to the df all, and I want to filter out those entries that had a missing value. So I need to refresh my memory. Let's look at the df we want to filter for anything that has non-missing status. So let's do that first. So I'm going to say we're gonna do this in a kind of the pipe stuff again. We're going to df space sub. We're going to say df space class. We're going to be a little gnarly here, but we're going to say filter. Actually, yeah, before we do that, what I like to do is I like to save new objects for the kind of the metadata things I need. So I'm going to say valid USS is, we're going to say df, what did I call it? Space class. Not space class, df-USS. Oh, so Yannick says, why is the pipe operator like this and not like what Unix has where it's this? Well, that's because in R, this operator is actually used in conditional statements to say like something or something else. So it's already taken. But that's an excellent point. Now, the pipe that's coming in the basic R installation in 4.1 is going to have a variation of it. I think it's going to look something like this, if I recall correctly. It's a little different, but it's got the vertical pipe in there in some way. So that's a great observation. So I'm going to filter this. I want so that not is.na status. So there's a couple of things here. Is.na is a function that for a vector of things tells you if it's missing or not. So for each element, it'll say, is it missing or is it not missing? So I want to filter for the ones that are not missing. And then I'm going to pull. Pull is a function to take a variable of this and then basically save it as a vector. So I want this one. I want to pull spacecraft class, and you can see it autocomplete for me. That's really nice. Oh, I see. Yeah. Exo is saying there's a proposal for JavaScript to use the pipe and the greater than sign as their pipe. Yeah, I think a lot of languages are starting to catch on to this, and certainly R is not the first thing to do it. Like I said, Linux and Unix have been doing this for forever. It's cool that languages are starting to do this. Okay, so let's see if this works. Oops. Okay, so valid USS should be a vector of 7 elements. We'll just type it out here. Okay, we got 7 elements and they're not missing. That's what I wanted. So now we're going to feed this into here. And we're going to filter. Now I forgot what the variables were called. Let's see. I think it's species UID. We'll find out. We're going to say %in valid USS. And then we're going to see if this actually gives us rows. I'm a little skeptical, but we'll find out. df sub gives 0. So that is not the variable I'm thinking of. So let's go back here and let's see if we can get to the bottom. Oh, it's UID. I think it's UID. That's my problem was. So it's not species UID, it's just UID. Okay. So this should give us, hopefully, some observations. So now we have 5 observations. So, okay, so that's interesting. So not all of those entries that we found in the first data set have a corresponding thing in the second data set. So that's interesting. Maybe a data cleaning thing. But we can view that. At least we have something. So maybe we can explore this. We'll do data table again. df space sub. Okay. Okay, so we got some interesting things here. Now, doing this with one spaceship might be kind of boring. You could do this same logic for all the spaceships that you're interested in. Now, let's say just for this set, maybe we want to do what do we want to plot here? I'm looking for any like quantitative things here. So we have number of decks. But what we could do is we could do this on the entire data set, because you can tell the rows in this are unique. That's what I wasn't sure about, is if the rows in this set would be unique. But we can start like looking at the distribution of the number of decks just visually. So to do visualizations, the package that's used a lot is the ggplot2 package. Why is it called 2 at the end? Because there was a first version of this that Hadley Wickham, the author, did a complete rewrite about, and he called it ggplot2, and the rest is art history, as they say. So what we're going to do is we're going to try this on the whole space class data frame. And we're going to define basically the roles of variables. And what you do in ggplot2 is you have this function called AES. I think that stands for aesthetics. And that's where you feed in what's your X and what's your Y and what's your color and all that stuff. So we can say X equal, and then it would be number of, that's capital of, decks. Okay. And then we're just interested in the distribution of this. So ggplot2 has all these geom functions. So we can say geom histogram. And what this should do, oh, I didn't. Oh, I thought I loaded the tidyverse already. Let me load that again. Oh, it's not ggplot2. Of course, it's ggplot. I was getting carried away. The functions are still ggplot, but okay. Oh, this is another thing I got tripped up. ggplot2 was built before all this pipe stuff happened, so you have to use the plus sign instead of the pipe operator. That's something that Hadley cannot update without breaking a whole bunch of backward compatibility. So it's interesting. It can trip you up quite a bit. So let's kind of take a look here. We can look at the distribution of the decks. We have a lot that are less than 10. Although actually these counts are actually kind of small to me. Oh, I see. So we have a few that are 40 and above. I guess we have a lot of missing data here, because that seems pretty sparse to me. Yeah, I'm glad no ship has 0 deck. That'd be a good data quality check, wouldn't it? If you saw that. But that's what visualizations are for. You can easily check that kind of stuff. So that's interesting. So we got that. I wonder if there's other things we can look at here, other things we can explore. In fact, let's do the view of all of this. So what did we call this? DF space class. Let's view that. Okay. There's now a lot more entries. I'm just curious if we have. Oh, what we could do is we could explore whether warp capable has any real impact on the number of decks. Maybe decks that can do warps have more decks or something. Who knows? But what we could do for that is we could now add in this a color aesthetic, and we can say warp capable. And this is where we can now get a histogram that's going to have those distributions kind of superimposed Oh, I always forget to do this. It's both color and fill as the same thing, because you can see the fill is still black there. But if we run this, so we see that it's not, I mean, it's still kind of random there. Oh, hey, Tan, welcome thank you for joining. We're exploring Star Trek data because I have a good friend here on this stream that really loves Star Trek and he wanted an intro to R, so I figured for my first Twitch stream, let's have some fun exploring it. So definitely we're seeing that the ones that are not warp capable, there's some of those have more decks, so that's interesting. Okay, so that's one piece of data we could look up. But see, visualization with ggplot is super easy. You just feed in your data frame, define what aesthetics you're looking for, and then the type of geometry that you want to visualize. And we can even change this. Instead of geom histogram, we can do geom density. And then we can simply get a much different take on this. For now, it's two curves here. They're overlapping each other. So, but that's another interesting take on, yeah. So that's an interesting take on how you can analyze the distributions of these things. So we can do some other interesting things with the tidyverse as well. We can go back to our stat APIs. In fact, I really like the data table view, so we're gonna do that here. Let's look at what other ones we could look at. The ones that have a lot of columns, I think will have a lot more data to work with here. There's a location. We did we could do performer, or well, staff must just be like the show staff. Let me go back here. Yeah, well, that was not cheap, Tan. That green screen set me back a little bit, but I've been taught by some very knowledgeable streamers that some are on this call, this stream. Gosh, I've been working too much on this call. I feel like I'm on a leash. Let's see, what data we can look at location, although I'm not very good at mapping stuff, but we could look at performer. Yeah, why don't we do that? Let's look at performer. So let's look at performer. So this API package, again, if you're new to this package like I am, it lets you see how many pages there are. Wow, 56 pages. That's going to take a long time to filter out. Yeesh. So maybe we do a slightly less verbose one. We can just do season, see what's in the season data here. Oops, wrong one. There we go. Okay. That's only one. Oh, that's easy. So let's pull the DF season. I'm not organizing this by any means. So we're going to do that same call. Then page. I think it will default to the first page anyway. So it's just, I didn't spell season right. All right. DF season has 33 observations. Does that have anything useful for us? This isn't so much the Star Trek lore or anything. It's just got 4 columns. Yeah, that's kind of boring. Yeah. What did I say had the species data set might be interesting. I think we can, let's look at that a bit. Species. Oh, that's only 6. Yeah, let's check that out. Let's do that. Let's see what species has. Species. And I'm gonna, oh yeah, I should do my my map call. Just gonna copy that again. Do that here. Now that had 6, so we're gonna do 5 because of the problem with that package getting the last page. And then let's do that. Should go to 5, and then we'll have a species data frame. Then, oh, interesting. Oh, duh. I forgot to coerce this to a data frame. That's why I had the error. So you have to be careful of your object types. And this should give me a data frame that we can view. All right, data frame. Let's zoom in on this a bit. Okay, so we've got 453 rows. That's a lot. And we got the different names here. Let's see. Yeah. Quadrant name. That must be like a location kind of thing. And we got a bunch of indicators. So it's not so much they're quantitative, but they're more kind of classifying things. So we can deal with that in a different way. I'll show some. But I'm trying to figure out, other than the name and stuff, there's no like quantitative information here. That's interesting. It's just more indicators. So I guess we could do some frequencies of things. Yeah, quadrant name may be the quadrant of origin. Yeah, that's true. So we could do a facet around that at least. So we could, what should we do for that? I don't do a lot of categorical analysis anymore. I do mostly continuous. But let's see what we can do here. I definitely want to count the number of, we could do the number of extinct species by the quadrant. Maybe we could do that. Now, because I'm lazy, I'm just going to get the names of this here. You can do the names of an object in R, and it'll give you, if it has an attribute to name things, it'll print that out as a vector right here. And so we got quadrant.name. That's where I want to kind of start doing some faceting on. Well, we can do, so we can say, we can do a ggplot again. Data equal df species. AS. All right, so we can do x equal extinct species. And then we'll do a plus, we can do geom bar. Actually, we should probably, I think this will work. Let's just give it a shot. Oh, I mistyped it. What was that? Hold on. Extinct, not exist. What was I saying? Okay. Let's see if that gives us something here. So, well, geez. Okay, well, most of them are not extinct. Well, that's not going to be very informative, is it? We can look at a different variable instead. Maybe warp-capable species is a more fun thing to look at. Warp-capable. And then, let's see, just at a high level, if this gives us... Yeah, that's a little more data here. So we see that not many are warp-capable. I wonder if that varies a lot by the quadrant. So in ggplot2, on top of these geoms, you have functions like facet, where you can define then what variables you want to use to kind of do different panels by a variable. And so we want to do quadrant.name, I believe. Let's see what happens there. And then we do a tilde, and we just do a period to say, okay, that's the only thing that's varying. And let's see what that gives us. Okay, so let's zoom in on that a little bit. Whoops, wrong button. You can't see that on the stream, but I popped the window out there. Viewer. No, not zoom viewer. Sorry. Zoom plot. Okay, so on the right side, we see the... Now that direction of faceting I don't really like. So let's change that. Let me go back to my... We're going to change the direction. We're going to do the dot to quadrant names instead. That'll give us a better direction on it, I think. Let's see if that does the trick. Yeah, that's a little better. So let's zoom into that. Zoom plot. Okay, that's... Oh, there's a bunch of missings. Oh, yes. Okay, okay. So that strikes again. So some of these species apparently are not associated with a quadrant. With that said, the rest that do have the quadrant populated, you see that basically it's almost always more are not warp capable than the ones that are, although it's by a very thin margin in the alpha quadrant. But then the delta seems to have the biggest difference here, and the gamma quite smaller. So now what's interesting is that you saw that the scale for these was defaulting to the last one here. It basically tries to do a unified scale that based on whatever is the biggest. And you may not always want that. You may want so that each panel or facet can do its own scaling. So in ggplot2, I believe that's a parameter in facet grid. Aha, so it's a scales parameter. So this is what I always do like every day when I'm coding up an app or a new package, is I look at the help documentation, refresh my memory, to see what I should do here. So right now it's fixed, but I want this to be, instead of fixed, I want it to be free. So we're going to say scales equal free. Now this should give us an easier view here. No, it didn't. So I must have, maybe it's free.y. Let's see if that does it. It's interesting that it, nope. That's weird. I wonder if I screws, maybe it's free.x, because that's an x variable. Maybe that's it. Joys of, nope, I must be clearly doing something wrong, but there, that should have helped. Okay, well, maybe let's try facet wrap. Maybe facet wrap's the better one. So I'll have to have about probably 10 more minutes before I have to, oh, I didn't look at my debugging. It's free_x, not .x. Okay, that. Let's see if this does it. Boy, that's still a fixed scale. Maybe now it's free.y or free_y with this. Yes, we got it. Well, that was a doozy, wasn't it? But we can look into this more. And now we see it's a lot more legible to see the overlap here. But you see delta at 40 that were not warp capable. So there's definitely more in the delta quadrant than what we see in the alpha or the gamma. The alpha and the gamma seem fairly similar in the overall frequency. And then the ones that don't have anything are quite missing there. So this is, again, me looking at a data set that I have heard about, but never really played with yet. You can kind of see how in one environment I can go from importing to summarizing to exploring and visually exploring it, all with very concise functions. So this is where R really came into play many years ago, is the fact that we could go through all these different parts of an analysis pipeline with pretty expressive syntax. And this was even before the tidyverse was a thing. You could do similar things at this, but tidyverse just gives you some more niceties to kind of feed that data frame of stuff into different sections of your pipeline. But it's definitely fun to start looking at this. And other cool things you could do is if you have like location data, R has packages to map certain things, and you can definitely spruce up your ggplots to be a different style entirely. There have been people that have made ggplot visualizations that look just like out of a comic book, which is straight up amazing in and of itself. But yeah. Oh yeah, so Yannick has a great question. Can R be integrated with stuff like C#? So not so much C#, but it does have very tight integrations with C++ and C, and even with Python and with JavaScript. There is even a newer ecosystem versioning with integrations with Rust, of all things. So it is very much interoperable with other languages. The one that's been there historically the most has been C, and by proxy, C++. In fact, a lot of people will recommend that if you have R code that's not performing as fast as you'd like, that if you can write your function in C++, it'll speed it up immensely. Because R does have some limitations with memory management, and if you're not efficient with how you straw up your code, you could run into some of those blocks. But with things like C++ and other frameworks, those are becoming more of a thing of the past. But certainly R from almost the beginning has been easily integrated into other languages. And so, yeah, there are even ways that from Python you could call R directly. But in terms of that integration, there's a package from RStudio called reticulate that gives you that binding to Python so that you could call Python functions as if they are R functions. And likewise with C++, with the RCPP package. That's been one of the most well-respected packages in the R community by far. So you can do almost anything with this stuff, really. So it's really your imagination that's the limiter. So the Star Trek package, this rtrek package, has a whole bunch of other things we can do with it. In fact, this is a little teaser maybe for next time, is you could do a ggplot with the font style of Star Trek. How cool is that? With the colors to match. And one that's really interesting is, let's see if it's in here somewhere. If you're making a web application with Shiny, guess what? I can make a Shiny app that looks like it's from Star Trek. Yes, this is true. I'm guessing I'm going to be challenged to do this at some point by someone on here. But look at that. That's a Shiny app. Like, isn't that crazy? That's amazing. So the author of this, Matthew, he found all of the styles that Star Trek uses, all the CSS, all the colors, like all those fonts and everything. And it's a simple like set of functions that you can use in your Shiny app to make it look as if you were a Star Trek designer. So yeah, maybe this is the hook that you need, Yannick, to start learning R. You make Shiny apps with Star Trek. I think you'll have a lot of fun with it. And there's obviously more to it than that. There's also packages, I think, to get to the actual fonts themselves and the colors. So Matthew's done a terrific job here. Now, of course, like any language out there, not every package is of the best quality, right? I mean, this is all from the community most of the time. Now, some have like a company behind them. Like the packages from RStudio are from software engineers at RStudio. So they're literally getting paid to work on open source, which is like the dream job, right? And then others are coming from academics that are writing their package to solve their analysis needs for their research. And frankly, if not for R and the package to implement something called competing risk methodology, I would not have finished my dissertation. Literally, that was the computation thing I needed to save my dissertation, was that package. And it was from the authors of the paper that I found in my lit review. So it really was at that point that I was like, well, if R can save my dissertation, imagine what I can do with everything else. So how long ago was that? I don't want to say, but those of you that are smart can probably figure it out. But yeah, I think this has been a great kind of little overview of what R is capable of. It also helped me iron out some kinks with streaming with Twitch, my first time doing it. So I got a little homework to do to fix stuff up, but I think I know what I have to fix. But certainly I hope to do more of these later on because I love looking at data. I love making apps that serve up data. Yannick knows that I've even made apps to help with our virtual racing league for Hotshot Racing, and the tooling that you all saw here was a big part in that, along with some other fun things with text extraction and CSS stuff. So yeah, I'm going to be playing with this more, and I think the feedback on here has already been a lot better than I've seen in some of my other streams, so this may be a regular feature. I wanted to use this as kind of a test run to see what people thought, but it seems like it was well received. And next time we may dive into more of the modeling piece or more in visualization. But there's always no shortage of stuff to do. So if you want to find out more what I'm up to, you can see that little footer there with my various things I'm a part of. And yeah, I hope to do this at least somewhat regularly. I want to make sure I'm cognizant of my friends that are streaming in our fun little Wimpy's World group. So we will just we'll figure this out. But certainly feel free to contact me. My Twitter handle you've seen scrolling there is @thercast, because @our_podcast has been taken by somebody who's apparently been squatting on it for years, and I couldn't get it when I first launched the podcast itself. But yeah, I certainly thank you all for tuning in, and I don't know when it will be again, hopefully pretty soon, but thanks so much for coming in, and we'll see you next time, and hopefully the buttons work. Bye bye everybody.